Welcome to a lesson on conjugates. Our objective today is to be able to use conjugates to rationalize the denominator. All right, so first let's talk about what conjugates are. And we're going to start with the difference of squares. So you're familiar with a squared minus b squared, and if we are to factor that, we get a plus b, a minus b. Now a plus b and a minus b are what we call conjugates, because when we distribute, we FOIL this out, the two middle terms cancel and we get a squared minus b squared. So we have to make sure that our two binomials, the first terms are exactly alike, the second terms are alike, but one is addition and one is subtraction. All right, here's your first example of conjugates. Notice I have two binomials. The first terms are both 3, the second terms are both the square root of 2. One is addition, one is subtraction. So let's see what happens when I distribute this as I FOIL it out. So if I distribute the 3 times 3 is 9. Then 3 times the negative square root of 2 is negative 3 square root 2. Now let's distribute the negative 2. That gives me a positive 3 square root of 2, and distribute the square root of 2 again, I get the negative square root of 4, because 2 times 2 is 4. All right, let's see if I can simplify any of this. I have some like terms right here and right here. If I add those two terms together, a negative 3 plus a positive 3, I'm going to get 0. So I'm going to bring down this 9. I get 9 minus, and of course the square root of 4 is 2, and 9 minus 2 is 7. So these two conjugates simplify to a nice whole number of 7. And notice that the square root symbols are gone. And so we're going to use this to help us rationalize the denominator. All right, for our first example, we have the expression 3 divided by 5 minus the square root of 2. Now we can't just rationalize this by multiplying by the square root of 2, because this is a quantity that has to stay together because it's separated by subtraction here. So the way we're going to rationalize it is we're going to multiply by what we call the conjugate. So the conjugate of 5 minus the square root of 2 is 5 plus the square root of 2. And if I multiply the denominator by that, I have to multiply the numerator by it as well, or I have totally changed the problem. We're simply rewriting it into a different form. All right, now let's do our multiplication. All right, in the numerator, I do need to distribute the 3, so that gives me 15 plus 3 square root 2. In the denominator, I'm going to change pens here to red. So I get 5 times 5 is 25. And because these are conjugates, the two middle terms are going to cancel out. But I'll go ahead and show you what those look like. Here you get a plus 5 square root of 2. Here we distribute, we get a negative 5 square root of 2. So you can see how those are going to cancel each other out. And then the square root of 2 times the square root of 2. The negative square root of 4. So let's keep simplifying. In the numerator, I just simply have 5 plus 3 square root of 2. And in the denominator, these are going to cancel each other out. And I end up with 25 minus basically 2 right here, which is a 23. So that gives me all over 23. And now we have rationalized the original problem to equal this quantity where there are no square roots in the denominator. All right, let's try another one here. Here we have the square root of 4 divided by 3 minus the square root of 5. And I'm going to go ahead and I'm going to put parentheses around this denominator so I realize, hey, I can't just simply multiply by the square root of 5. That's not going to work. Instead, I'm going to have to multiply by the conjugate. So rather than 3 minus the square root of 5, I'm going to have 3 plus the square root of 5. And the same up here. Now I'm also going to do something else real quick here, because I noticed that this is the square root of 4. And if you're okay with that, let's just go ahead and simplify that. and that equals 2. And then when we get to distributing, we don't have to deal with that square root of 4. So let's start with a numerator, and again we're going to distribute, and I get 2 times 3 is 6, plus 2 square root of 5. So that's distributing here. In the denominator, because these are conjugates and I know the two middle terms are going to cancel out, I'm going to shorten my distributing to simply 3 times 3, which is 9, minus the square root of 5 times the square root of 5, which is the square root of 25. And I can simplify all that to 6 plus 2 square root of 5. And that numerator, because it has addition, you can, if you want to, you can put parentheses around it to say, hey, that quantity stays together. And on the bottom, I have 9 minus 5, which is 4. In this case, we can actually simplify that just a little bit more, because I can divide both the 6, the 2, and the 4 by 2, and that gives me 3 plus the square root of 5 all over 2. We can also have conjugates with imaginary numbers, and they work very similarly. In this case, we have the same two terms, 3 and 3, and the same second terms. This happens to be imaginary number, I and I, one's addition, one's subtraction. And if we multiply this out, so if we FOIL it out, 3 times 3 is 9, 3 times negative I is negative 3I. Here we get I times 3, which is a positive 3I. You can see how those are going to cancel. And I times negative I is negative I squared. Alright, so this term and this term, these are kind of what we call like terms, they're going to add up to 0. So what I have left then is I have 9 minus, alright, let's recall what I squared is equal to. I squared is equal to negative 1. So I can substitute in a negative 1 here. That gives me 9 minus a negative 1, which is 10. So conjugates with imaginary numbers work very similarly. So if we have this rational expression with an imaginary number in the denominator, all right, we can get rid of that imaginary number in the denominator by multiplying by the conjugate. In this case, it would be 4 minus I. 4 minus I. Okay. Distribute. I'm going to start with the numerator, and we'll get 8 minus 2I all over. And again, I know that these are conjugates, so the two middle terms are going to cancel, so I can just multiply 4 times 4 and get 16 minus, and I can do the last two terms, which gives me I squared. Let's keep simplifying here. On the bottom, I get 16 minus a negative 1. And the numerator, I still have 8 minus 2I. So that denominator is going to give me 17. In the numerator, 8 minus 2I. So you have rationalized that with imaginary numbers.